Hi, I'm Rob Sin. I'll be the instructor for your game theory course this semester. And I want to show you a few tools on the web we'll be using throughout the semester. This is my faculty web page. And why I'm showing you this is the white links. This will be a link to the online course notes. And the yellow links down here, these will be links to the resource page. And what's on the resource page, let me show you. Um, Sorry, let me just click on this. And so I hope to have the presentation files. So you'll have course, so you'll have notes for the PowerPoint looking things that I show, the presentation slides that I show. And hopefully you'll have links to the different things that we utilize in the class. Of course, our course notes are here. Um, we are going to be looking at graphics. Um, and so this is the content that we'll be using today, and we're going to be working inside the UNG Datahub. So let's talk about that, all right? So first of all, we're going to try to complete 1 to 2 modules per week. I really enjoy our online textbook by Nordstrom. She presents a discovery approach to game theory. It's very readable. It has a lot of check your understanding um, questions which are great. They're really great questions, and they have you thinking about the right things to help you become more successful at game theory. Um, so we're going to be doing 1 to 2 modules per week. The first half of the semester is zero-sum games. Why? Well, because the whole theory of non-zero-sum games is built on the theory of zero-sum games. So we can take our learning from the first half of the semester and immediately apply it to non-zero sum games. So our modules will have quizzes or homeworks. We'll work in the Data Hub and you'll see an example of that notebook right now. What I'm going to do is I'm going to post both the Data Hub link and the YouTube link for the video in D2L. And you should go through the video with the Data Hub notebook open so that you can work along with the video on the examples. All right, so we'll do the same examples together and you'll learn the commands you need to know. Um, there will be 2 tests, final exam. And I've talked about the Data Hub. So what is this thing? Well, um, the UNG Data Hub is a nice digital portal that has these notebooks created. We have this MIST Markdown language, which allows us to present text, and we have different formatting of that text that makes it easy to write our notes. It also utilizes the Python programming language. Now, we don't really need to program much, but the commands we can use will serve as our scientific calculator, our graphing tool, and we can write a program for a game theory solver, a matrix game solver. So we'll do that. Also, in the MIST Markdown, we have this LaTeX equation editor, and it's publication quality graphics, right? It's the best equation editor out there. Some modern folks, especially on the tech side, the more computer programming side, call it $ mathematics. Why? Well, because we set off the mathematics equation from the text using $signs. We enclose it with $signs. So there's $signs all over the place when we code in LaTeX. And you're going to receive your own portal inside the Data Hub and you're going to have all your own class files. And when you make changes and you save them in the hub, their changes are permanent. So you're going to have the same files all semester, and when you save them and update them, um, those changes persist. All right. And I want to talk about this private and protected. Okay, so it is password protected. It's private. No other students can see it. However, your professors, there are 3 or 4 of us in the math department that are admins for the Data Hub. Why? Well, sometimes there are problems with the Data Hub. Some file gets corrupted due to a power outage or something, and we can go into your area of the into your portal and help resolve some issues, right? We don't go in there, generally speaking, but it's a fail-safe, helps situation, um, just in case. All right, and but it's private to a point. Yes, your professors can see what is in there. So just know that. And you access the data hub. I'll provide links, and you just use your UNG credentials. Um, and the first module we're going to do, we're going to learn how to use Python for graphing. The first thing that's going to happen when you open a notebook is there's going to be an initialization section. There's going to be a code block that imports all of the tools that we're going to use, the different packages and environments in Python that we need. Then we're going to create a graphing window. So let's take a look at that. Let's jump over to the to the notebook, right? This is our non-zero sum game section. And right here is the initialization code, okay? And what are we doing? NumPy and SciPy are some of the packages that we use. Um, the linear programming in SciPy is going to help us. We're going to use the matplotlib, right? The mathematics plotting library in Python. And we have this alias plots, right? So whenever we type plots, it's going to access a bunch of commands for us. All right. Um, so with the initialization block, we are just going to run it. And you run it by hitting the play button here, or you can run it by hitting Shift Enter. When you hit Shift Enter, it does the same thing as the run. It executes whatever commands are in that cell and then goes to the next one. All right. And graphics for game theory. So we're going to start by creating a graphing window. Sorry, let's check that out. All right. So we're going to create the graphing window and the XY coordinate axis. And the way we're going to do that is we're going to use plots.figure. And then the only argument we're going to send in there is fig size equals. All right, so it's got one option, one parameter, fig size. And what are you going to use? Well, anywhere between 5 by 5 and 8 by 8 works well. By the way, you can create rectangular windows depending on the kind of graphics you're trying to display. Um, so plots.figure, fig size, I'm using 5.5, 5.5. That just works well with my, your screen resolution on your laptop is different than mine probably, so we're going to choose fig size just to make the graphics readable. And it's your preference, right? There's no right or wrong answer with the fig size. All right. And then to create the X and Y axis, right, we're going to use plots.axh line for the horizontal line and axv line for the vertical line. All right. Zero, that's the x equals zero, y equals zero. It places it at the origin, right, essentially. We can tell it the color. We'll generally use black. And then line width equals 1. By the way, you can abbreviate line width as LW. 1 is good. Probably never need to go any bigger than 2. And again, there's no right or wrong answers here. You can adjust the line width to what makes sense for you. And let me get rid of the scribbles there. Let's jump in. So we're going to do, right, um, so plots dot window, right? And fig size 5.5 comma 5.5. And hang on just a second. I believe I've gotten that command wrong, right? Plots.figure with fig size equals. Okay. So plots.figure, and we want fig size equals. And let me just make sure. Yeah, so fig size equals, and then I have the coordinate pair. All right, so fig size equals. And by the way, this is why we have the the course notes online. Do your professors always remember every single command? Um, Know and remember with Python, the commands have to be word perfect, capitalization perfect, any. Now it is kind of nice that it kind of ignores the spaces, so you can put in spaces to help your eyes adjust. But here we go. This has created the graphing window, and now we're going to create the um, let's create the x-axis, right? So the x-axis is going to be a horizontal line, right? So plots.axh line. And let me just give a little room here. Plots.axh line. And we're going to do y equals 0, right? It goes through the point y equals 0. It's a horizontal line. And let's do line width equals 1 and color equals black. And of course, I didn't close the parentheses. Notice that Python, when it throws errors, the last line is the one you want to read. It's the most helpful information. And it even has a little arrow pointing at the mistake that we make. And there you go. Now you're going to point out, I'm not seeing the x-axis on this. Well, give it a second, okay? And then we can do the plots.axv line. We're going to do x equals 0 and line width equals 1 and color equals black. Okay. And you're still going to point out, hey, Dr. Sin, it's not working. And that's fine. We'll sometimes use this, plots.show close parentheses, um, and we'll figure this out. I'm not quite sure at this very second why it's not showing up, but I'll be right back with you. Okay, and I'm back, and so what was missing was the X limit and the Y limit. In other words, this is just drawing the pixel size of the window, right? The plots dot figure fig size just gives me the graphing window size. The plots.xlim, that's the area of the x-axis that I want to see. And plots.ylim, that's the y-axis, the portion of the y-axis that I want to see. And so when I include those, you can see that I get a nice graphing window. And we can see those portions of the x and y axis. And why negative 0.5? Excuse me, negative 0.5, if I just show from 0 to 5, right? The problem is I don't see the axis, right? Because I haven't gone far enough over. So all I'm doing is going a half unit beyond the origin, both for the x and y, and that way I can actually, I want the origin included inside what I'm showing with the x lim and y lim parameters so that I can see the coordinate axis, okay? All right. So, by the way, these commands um, are going to be pretty much how we start all of our graphics, right? So let's um, go ahead and copy this. Why? Because task 2 may require exactly that sort of thing. And I can, get rid of the spaces. The code will now run wherever I copy paste it to. And that's something to remember, that once you've created code that works, a lot of times it's quicker to grab that code and copy paste it into the next task. So what's the next task? We're going to draw horizontal and vertical lines. Okay. And by the way, this also points out um, I should have done this slide before, right? This was the reason that my graphics weren't showing, because I did not have my X limit and Y limit defined. Okay. So sorry about that. Um, And again, reinforcing the point that we're just going down to negative zero point 0.5 to show the axes. Why do I not go to negative 1? Well, you can do it. Put in negative 1 for both the x-lim and the y-lim parameters, and you'll see that the labels on the x and y axis start to merge together. The space below the origin starts to get muddled with too much graphics, right? So um, zero point 0.5 is negative zero point 0.5 is what I like to use after trying to solve the muddle. Okay, and so for the horizontal and vertical lines in game theory, we talk about security levels. This is mostly during non-zero sum games, so this might be a few weeks before we hit this. But we occasionally want to draw a horizontal or vertical line. And again, they're the same commands that we're using um, for our axes, right? For the coordinate axes, AX V line and AX H line. Now, also I want to note that, right, please notice that this plots, we start everything with plots. Why? Well, remember, plots is the alias we used when we imported the matplotlib, right? It's the mathematics plotting library. So all of the functions that we want are stored in that library, and we're just calling it this alias plots. I'm going to use that this semester. You'll see a lot of people use PLT for the alias that they use. But again, that relates back to how we imported. Okay. And again, it's the same two commands, same options, right? Except notice that we have label. All right. So what's going to happen is we're going to have a graphing window, and then Python will include a little legend that will describe, which things go with which. Um, so that label or legend, it's referred to in different ways in different commands, but you'll get used to it. And we do like the legend. Often the graphics are a little complex, and if we have a legend, we can see which line. Okay, so the lines that we're graphing are going to relate to strategies, whether it's the row player strategy A or the column player strategy B. So the legend will help our eyes focus on which strategies are which. Okay. And again, we're going to use pretty much the same commands that we just did, except notice that the label equals, and then I put inside single quotes what I want to label that. Also, you'll find that there are line style commands. All right. And line style, we'll have to play with that a little bit, and I can show you some more uh, about that in a moment. Okay. So let's jump into our let's jump into our notebook. Sorry, that's what I wanted. Um, okay. So again, task 2, we have just got, our window, our coordinate axes, we have our limits on the coordinate axes. Okay. And by the way, you're going to learn very quickly that if you want to draw, and by the way, these pieces of the task differ from, I think, what I put here, and I'm sorry about that. Okay, but let's do a line through x equals 2. But I can take this coordinate axis, right? And if I want a horizontal line through y equals 1 now, okay, y equals 1. That's going to be my horizontal line because I'm using H line. And let's do the color equals red, and we can try line width equals 2, and let's graph that. Okay. And you can see I made it a little darker. All right. And then this line style, right? So let's jump back to the slides, right? You see line style equals, all right, and what are our options there? Okay, and I believe, right? And I don't know that you can see these. You notice a dash followed by a period. We can use colons. Um, we can use the shorter dash. I believe that's a double dash that that my presentation slide is kind of collapsed into one, but let's try it. Okay, so these are the different line widths that we have access to in Python. Let me get rid of the markings. Okay, and that's line style equals, and let's do dash dash. So I'm doing a double minus sign there, and then I'm going to close quotes and let's see. And you'll notice the dash dash gives me a dashed line. And what did they say? They said, oh, colon was an option, right? What is colon? Oh, colon is kind of a dotted line. A single minus sign is just the line, a single dash, right? So there are different options and structures I can give to my line. And I kind of like, for these purposes, the double dash there, the dashed line. Okay. And I want to do the same thing. So I'm going to copy, paste, and I'm going to change the H line to a V line. And we're going to go through X equals 3 is what they said. And we want one red and one blue. Okay, so change the color equals blue. Line width is fine. Let's use a different line style on this one. Cha-ching. Again, just trying to show you the different options here. Um, and you see this stuff keeps printing out. And again, when we use the plots.show, it collects everything together, shows it all, and I stop catching these stray outputs from different pieces of the code. So this is what we did in task 1, and here are the lines for task 2, and we often do this at the end. What does this do? It gathers all the active plots into the single active graphing window, right, and displays just that without any um, stray marks coming in as the commands execute. Okay, so we've got all kinds of different options, and I've shown you how to change the color and the line style and the line width. Label, again, text used for plotting the legend. And let's jump back up. This actually asked us to show that, so let's do that, right? The command is just label equals, and then I put text. All right, label equals, and then I put text, so we can do that. See, so come up here and I'm going to go label equals, and inside the single quotes, I'm going to put text, which is I'm going to put, I don't know, let's call it line Y equals 1. Okay. And at the moment that's not showing up, let's not worry about that too much. And we'll do label X equals 3. And then let's do a plots.legend. There you go. So you can see now that it's brought in the legend. And we have different options for placing that legend. Here it's actually covering up some um, of the graph that we want to show. So we'll want to be careful with that. Um, but again, just notice that the labels are the text that goes inside the legend, and then I have to turn the legend on inside the graphics window to make them show up. All right, so let's leave that for the moment. And we can scroll down. And by the way, I left lots of open cells here as places to work. Why? Well, a lot of times we do guess and check a little bit, right? You know, oh, I think this is the command. I'll plot this other thing. I'll see what's working. So I try to give you plenty of room to work. And now we're going to talk about creating lines between 2 points. I got to point out a couple more things. First of all, I want to point out alpha, and this works in a lot of different plotting functions. Alpha is typically the transparency level, all right? So 0 and the graph item is opaque. Excuse me, 0 is invisible. You can't see it at all. 1 is completely opaque. And you can use things like 0.5, 0.6. Why? It'll show a little bit of the stuff behind it, right? So you can set the transparency a little higher to get, when you have multiple graphic objects, you'll be able to see through them to the stuff below. Um, And again, that's not one that you can get right or wrong. That's one that just helps you see things. Okay. And again, plots.x label, plots.y label. Okay, well, let's jump back in and see what that does. Before I copy paste down to task 3, let's go back up here and let me do plots.title. And inside quotes, I'm just going to say graphing horizontal and vertical lines. Why? I just need a title. It doesn't really matter what that title is, plots.title, and you can see it puts a big bold title at the top and centers it, right? So let's just show it if graphing lines, and you can see that it'll be centered. Okay. And then I can try plots.xlab, right? Which is, let's say, row player strategy. And notice you read the bottom line first. It says no attribute xlab. So is it x label? Yes. Um, so I abbreviated and it wanted me not to. So row player strategy. And then I can change this to Y label. So I'm going to copy paste, change the X label to Y label, switch to column player strategy, which is how we do it. Generally speaking, we will use the row player strategy on the x-axis and the column player strategy on the y-axis. Also, our current textbook doesn't do this as much, but Strafen, a game theory book that I do highly recommend, uses rows and Colin. Rose plays the row strategies, right? She plays the rows. Colin plays the column strategies, so Colin. And again, I'm just changing the title so you can see how the X label, Y label options work and how the graphing title works, okay? And we can take all of this and copy paste it down to task 3. All right, but I want to get rid of these. Why? Well, you'll see. We have to graph these points through 2 lines, okay? And how are we going to do that? Well, oh yes. Um, These are just covering the things I just showed you about plots.title. Plots.grid I didn't show you. So let's do that. Let's add this option here. And you can see plots.grid. And yeah, I need this stuff in here, I think, to make it show. Here, let me do it here. The grid, you can see kind of the gray lines behind it. That is the grid. So I can do plots.grid. Okay. And that should work. I'm wondering if there's a setting that I need in here. Is that the alpha? I'll have to play around with it and find out. Yeah, so then the alpha again is controlling the transparency. So I can create darker grid lines as alpha gets closer to 1. You don't always need very dark grid lines. Again, they're just help guiding your eye. It's easy with these horizontal and vertical lines, but they'll be helpful. The grid lines will be helpful when we do a Well, a line that's not perfectly horizontal or vertical. Okay, so plots.grid, and then I just specify a transparency level for it. All right. Um, and it's glitching at the excuse me, it's glitching at the legend, right? Because there's nothing to make a legend for. If you want to get rid of this little baby error that it's throwing here, you can use a comment for the plots.legend line, and now it'll just show what it's showing up above. And we'll take this comment out in a minute when we get something to graph. Okay, so let's look at how we graph these things. Okay, so the first thing we do is we create a list of points, and notice that we have the parentheses on the outside, then two ordered pairs. Okay, so those are x comma y. We want 1, 4, and 5, 3. 1, 4, and 5, 3. So I'm going to call them the points equals, and I'm going to do the outside parentheses. Then I'm going to have 1 comma 4, and then a comma, right? And then what was it, 5 comma 3? Yeah, 1 comma 4, 5 comma 3. Those are going to be my points. All right. And it isn't graphing anything. Why? Because once I tell it the points, I have to use the points.plot function to create the line. Now, this is a lot, okay? Color and label we've already seen. Look at this. This is the asterisk zip and then the asterisk points. And the marker makes sense. That's going to be, how we mark the points that we're drawing the line through. And it's just a lowercase o at the moment. But what are the asterisks for? Well, it turns out that Python wants a list of the x coordinates and a list of the y coordinates, which is just not how we work as in mathematics, right? We work with the coordinate pairs, and so what we're doing is we're unzipping the coordinate pairs and isolating all the x's into a list, and isolating all the y's into a y coordinate list, and then we're rezipping it so that Python can read it, right? So what all the asterisks are doing is they are allowing us to pull the ordered pairs apart and put them in the right format for Python. Okay, put them in the right format for Python. So plots.plot, and it's going to take me a second to get all of this typed in. Okay, so plots.plot, and we're going to do asterisk zip, and then asterisk points, right? So we're unzipping the points list, right? And now we're adding the options, right? So we're going to do marker, color, and label. So marker equals color equals and label, let's say label equals, I don't know, let's call it rose at the moment. I don't know what we'll need. I'm going to close that parentheses and go back. Marker, remember, is going to be lowercase o. Color, I don't know. Let's try green. Okay. And now, okay. Now we have drawn a green line, and notice that it goes through x equals 5, so our x limb and y limb aren't that great. It's cutting off just a tiny bit of that picture. So I'm going to change my x limb and y limb. Why? Well, now it's going to show more of the x and y axis so I can see this better. Okay, so again, we're going to adjust the x limb and y limb to make things work. All right, but they ask us to do another point. And what I'm going to do is I'm going to copy paste. I think you'll notice me doing that a lot. Why? Because if I get a command working, I want to leverage that, right? So I'm going to call this points 2. The list is going to be points 2. And I'm going to change the color. And I don't know what they have. Do they have pink? Pink and green. And then what are the points that we need? 2, 1, and 5, 5. Okay, so change this to 2, 1, and this to 5, 5. And we'll call this one Rose B. And it does have pink. I didn't know. Um, by the way, a quick Google search on, Python um, colors, right? It's got certain ones that it knows by name. So the Python named colors. And I mean, sky blue is one of them, but I don't know all the names. I just try things like orange. Does it have orange? Well, apparently it does. Okay. Notice that it does have labels, but we have turned the plots legend off, so I can turn that back on. And now you see the legend showing in the top center. That's not horrible. I will show you in a future video or future exercise that we can have the label show down in the bottom right, which is often better. It just gets it out of the way of the graphics we want to see. Okay. And then the last thing we're going to do is we're going to plot a polygon. Okay. So how does that go? Well, again, Python wants a list of X values and a list of Y values, okay? And we're creating this, notice, with square brackets, okay? So 14531 for our X's. Oh, wait, I'm gonna first copy a bunch of this stuff. Why? Because we need most of it. Not all of it, perhaps, but most of it. I'm gonna get rid of these two lines that we plotted, okay? Um, the title I'm gonna change to graphing polygons. And at the moment, I'll just call the axes rows and column, and I'm going to comment out the legend so it doesn't throw that error every time, right? So we're just back to our basic graphics. I'm going to change back to 5.5 till I know what we have to do. And then I want my X list with the square brackets. And what did we say? We want 1, 4, 5, 3, 1. And then y equals, and I'll have to see what those are supposed to be equal to. Yeah, so 14531 and 11463. 1, 1, 4, 6, and 3. Now, the xlim and ylim aren't going to be big enough, so you just saw me change them to 7s. Why? Well, because I have a 6 along the y-axis, a 5 along the x-axis. I like square graphing windows. We could do 6 and 7. You can do a rectangular graphing window. And this doesn't show anything yet, although it has changed our axes, as you can see. So now what? Well, we've got two more commands, one that creates the interior of the polygon and one that creates the vertices, right? So you're going to see the edges right away when I do plots.fill. Okay. And so let's do plots.fill. It's going to ask us for the X and Y coordinates, which we named X and Y, and then color, edge color, line width, and alpha. Okay, so plots.fill, X comma Y. Let's do a line width equal to 2, a color equal to sky blue. Okay, and we need an edge color and an alpha. Okay, so our color is sky blue, and our edge color, these are the um, edges of the graph. Um, what do they want? They want navy. Okay, navy blue. All right, I'm thinking blue. Why? Well, you'll see. Let's just graph this. You'll see that the interior needs to be a lighter color, um, and the edges a darker color. It just helps. And also, what do we want to do? We want to do our alpha, our transparency, right? We want this polygon to be um, alpha, and I'm going to try 0.6, right? And now I can see the grid through the polygon Also, if I draw lines over the polygon, right, that we may need additional graphics, right? I may need to draw a line through here and a line through here. And again, transparency just helps me adjust the different objects so that I can see what I need to in the picture as a whole. Okay. But if I want to see the points, right, at the moment I'm not seeing the dots at the vertices of the polygon. All right, so let's jump back to the PowerPoint, and that's going to be put in with the scatterplot function. Okay, so plots.scatter, we're going to tell it what the X and Y coordinates are, what color we want, and then z order equals 5 is going to add, well, it connects. Let me think about that. I am actually uncertain of the z order parameter right as we are talking. So let's just put it in. Um, so we're going to go with plots.scatter x comma y, what color equals, and again, we just want something different, y, so that it's showing, right? It's showing these points, okay? And then they had a last option that I'm not sure of. The z order equals 5. So we can add that in, comma, z order equals 5. All right. Again, if you want to show the vertices, well, let me explain. The vertices are going to be specific outcomes in the matrix game. So the specific outcomes in a matrix game are ordered pairs, an x value for Rose's value and a y value for Colin's value, right? So sometimes you do want to see the points and not just the line displaying on the edge of that polygon. And it turns out that the payoff polygon shows all the possible outcomes of the game that the players can achieve. Um, so this is a really good thing that we're using. I don't really need a legend in a polygon. Um, I suppose we could label the points if we wanted to, but it starts to get messy to do so. So we probably won't. All right, so that's a good explanation of all the kind of cool graphing options that we have in this class. And I'll be back to talk about dollar sign mathematics and LaTeX and MIST Markdown in the next video.